All right, so this is Chapter 4, Section 7, Congruence and Overlapping Triangles. Our learning objective is to identify congruent overlapping triangles and to prove two triangles congruent using other congruent triangles. So the first example we're going to see of that is problem number 1. It says, what common angle do triangle ACD and ECD share? So the first thing we do is we separate and redraw the two triangles we're interested in. If you look over here, there's a bunch of different shapes that could be triangles. So you want to make sure you highlight the ones you're interested in. So in this case, it was A, C, D, and E, C, B. So what we do is we take our first triangle in green here and we redraw it, ACD, all by itself, not inside the figure. We take the second triangle, BCE, and redraw it by itself. The angle that we've written twice is our shared angle. So in that case, it's angle C. All right, so take a look at this figure here. It's this nice little rectangle with diagonals going across, creating a bunch of different triangles. So we are going to just focus on triangle ABD. So let's highlight that. A, B, D is that triangle there. And DCA, D, C, A. So we are going to redraw A, B, D. This is an A. It's hard to tell. And we're going to redraw DCA. So the common side in triangle ABD and DCA, it's the one that we drew twice. Which side did we draw 2 times? Did we draw AB here and AB here? Did we draw BC here and BC here? No. But we drew which side twice? We drew AD twice. AD is the common side, and if you look at the diagram, it is right here on the bottom, shared by both triangles. So now they changed the question on us. If we look at B, what is the common side in ABD and BCA? So they don't want this one anymore. They want BCA, which is BCA is here. So let's draw that. So what is the common side for these two triangles? Which one, Bryce? BA, for sure. BA is the common side. The difference is negligible.
Oh,
All right, so let's take a look at this problem here. We have triangle ACD is congruent to BDC. We want to prove that CE is congruent to DE. So we want to show that those two sides are congruent. So what we're going to evaluate is, what do we know? We know that two triangles are definitely congruent. So triangle ACD is congruent to BDE. We know that triangle ACD and triangle BDC are overlapping triangles. So what we need to know is, what are the common parts of triangle ACD and BDC? And the plan to do that is we're going to show that the triangle ACE is congruent to BED, and then use the corresponding parts. So EC corresponds to ED. If we can show that these triangles are congruent, then we can show that those side lengths are congruent. Because remember, corresponding parts of congruent triangles are congruent. All right, so let's actually prove this. So I'm gonna have a statement and a reason. What is usually the first thing we state in a proof?
The given.
A given. So for sure we want to state that given. So we're gonna say triangle ACD is congruent to triangle what? BDC. Awesome. Then we're going to make a little congruence statement. So in triangles ACD, and I'm going to draw those out so we can have a better view of what we're talking about. We know that these two triangles are congruent. Therefore, AC, this side, is congruent to what side over here? AC is congruent to which side over here? BD. Thank you very much. Because corresponding parts of congruent triangles are congruent. They gave us that these triangles are congruent, so we're not making anything up. We're just taking what they're telling us. So, also, angle A is here. Who does he correspond to over here on this triangle? Yeah, angle B. Okay, so we've got a side and an angle. We're looking good. Awesome. I'm looking at here, I can't see any vertical angles here, but I can definitely see some vertical angles rolling up here, right? So BED, this angle right here, is a vertical angle to whom? Yeah, AEC, or you can write it as CEA. So these two angles are vertical angles, and I promise you, you'll see this all through this chapter. Vertical angles keep coming back around. So we want angle, angle, side. We've shown that angle A is congruent to angle B. We've shown that AC is congruent to BD. If we redraw this triangle, right here in red, it's the little bow tie one. And then this one. So we can see that these two triangles here, by angle, angle, side. So triangle BED is going to be congruent to triangle AEC by angle, angle, side theorem. If we know that these two triangles are congruent, we can say that CE is congruent to ED because corresponding parts of congruent triangles are congruent. All right, so let's look at this problem here. We are given that PS is congruent to RS and that angle PSQ is congruent to RSQ. Those are marked on our diagram here. We want to prove triangle QPT is congruent to QRT. So what we're going to do is I'm going to redraw those guys outside of this tangled mess of triangles that are living over here. And right now, there's nothing congruent going on within our triangles that we're interested in, the green one or the red one. All right, Santana. Love it. So we know that PS is congruent to RS. So let's do statements and reasons. So PS is congruent to RS is what reason? Kevin, please. It's the first.
Yeah, you know.
So tiny. Always given. Number one.
No matter
Given.
what. Given. Given.
The next piece of information is PSQ is congruent to RSQ angle. And that is also given. Not always. The next thing we want to say is that TS is congruent to TS. So right now we're looking at these two triangles here. So we said that PS and RS, we've said that angle PSQ, which is this guy here, is congruent to RSQ. And then we've just said that ST is congruent to ST. And that QS Did you guys see I'm changing that to the S because I mislabeled that? And that QS is congruent to QS. When we have a statement that kind of mirrors itself over the congruence sign, what is that? What is usually the reason for that? Yes, reflexive property. All right, so we've marked, every time we get an item, we mark it. So look at our blue triangles here. What do you think we're going to say about these blue triangles? If I have an angle, a side, and an angle, Bryce? Yes. So we can say that triangle please. The triangle PST is congruent to triangle RST, and triangle QPS is congruent to triangle QRS. Okay, so we're going to add a third set of triangles here. And if I could just stop mislabeling my triangles, life would be so much easier. Okay, so we're going to make this triangle here PQT and QRT. We are going to put in one more set of triangles. That's going to be PQS and, it's not erased, QRS. And then let's throw down some congruence. We know that PS and SR. We know that this angle and this angle. And we know that SQS and QS are congruent. So thankful. Okay, so now we're back on board. So I know that these two triangles here are congruent, and these two triangles here are congruent by side angle side. Now we're going to solve, but there's going to be a whole bunch of corresponding parts of congruent triangles. So we're going to say PT is congruent to RT, and PQ is congruent to RQ. Both of them are by corresponding parts of congruent triangles are congruent. So we put that on our mark it here, PT and TR, and PQ and QR. Not ever going to make this bigger. So QT is congruent to QT by the reflexive property, and triangle QPT is congruent to triangle QRT by side, side, side. All right, so let's look at this problem here. CAD is congruent to EAD. Angle C is congruent to angle E. We need to prove that BD is congruent to FD, which is right here. Marks. So if you draw the different triangles that are there, ABD and AFD are congruent. Angle A's and angle D's are congruent. And then you draw the other triangle, ADC and ADE. In that scenario, angles A and are congruent, and angle C and E are congruent. The other triangle is AFC and ABC. In that triangle, C and E are congruent. And in the baby little triangles, BDC and FDE, angle C is congruent to angle E. So which triangles are congruent by angle, angle, side? So we're looking for, if you look, AD here is congruent to AD here. So this goes angle, angle, side. AD and AD here, that's angle, side, angle. We look here, there's no, the other two do not have. So triangle ADC and triangle ADE, because angle CAD and angle EAD, and angle C and angle E, and AD and AD are congruent to each other. All right, so which angle is congruent by angle, side, angle? That's this one. This is angle, angle, side. Let's pull it. So triangle BDC and triangle FDE, because D is congruent to D and CD is congruent to ED, since corresponding parts of congruent triangles are congruent. So you take a look at this little guy here. And pull information based on our corresponding parts of congruent triangles. Oh, this one. And since BD and FD are corresponding parts of congruent triangles, they're right here. Then triangles BDC, then they are congruent. So corresponding parts of congruent triangles are congruent.